your hint that you should be integrating with respect to, actually you tell me why, like in this one you integrate with respect to y, but everything's isn't in terms of y anyway, so that's, I guess not you tell me, but I'll tell you again. That's your hint that you should probably integrate with respect to y. Everything's already in terms of y. If it's in terms of both x and y, like neither are solved for, you can choose. You just solve for one of them and go. This one is kind of weird to graph, right? I feel like that's the weird part. So what I do to just for getting the graph, and then I ignore the other what I'm about to do. I get it in terms of x. So I would say for this y equals arcsine of x. There's a problem with that because arcsine has a restricted domain. Here, this is not a function because it's sine and it's going up, like upwards. That wouldn't be a function. However, arcsine is a function. It's truncated to look like that or something. So when we graph it, we just have to realize there's actually more to the graph. But using arcsine limits what our graph looks like. And then this one's easier to solve for. Y equals pi over 2x. So now I can graph those in my graphing calculator really easily and see what it looks like. Y equals pi over 2x. This is just a line. I know that. And then we have something, I'm exaggerating, but it's something like that. And I'm supposed to calculate this area. Do you notice anything about that area? We just said up here that even if you had functions below the x-axis, if it's area between two curves, you'll never get negative area. So the area does not cancel out. Remember, because if the functions are below the x-axis, that area would be negative, but we're subtracting that area. So you're subtracting a negative, it's positive area, yeah? So that won't happen. But within whatever you said is something. It doesn't cancel out. It's just double, right? Double that. Or double this. So we can just calculate the area for one of those. Yeah? So, let's wait. Now, like, we're trying to figure out where they intersect. I'm going to try and figure out this one. I know that for regular sine of x, my function looks like that, and the highest point has a y value of 1. Yeah? Do we understand that? And from my graph, it looks like that's touching at the peak of my, I guess, amplitude, or what, crest? Crest? Trough? No, trough is the... the top of the function. I'm guessing that it's a y value of 1. The graph is super important to have, so, whoops. So, if I wanted to figure, so now I'm going to ignore those, because those are in terms of x. I'll integrate with respect to y. Ooh. Which is the top function, if we're thinking about integrating with respect to y?
Well, it depends on which side you do.
Oh yeah, so let's focus on this side. You're right, it does depend on the side that you're doing. So which one is the top function? Sine of y, yeah. So if you're integrating with respect to y, the top function is the one that's closest to the right, or the one that's farthest to the right. That's what I meant, farthest to the right. Do we understand that? This function is farthest to the right side. If you just turned it on its side, it would still be the top function. So, we can integrate. Oh, and let's see. So I would set these two equal. Sine of y equals 2 over pi y. And then I would guess a point of intersection. And if you plug in y equals, oh, wait a minute. Oh, it's not 1 anymore, but it's what makes it 1. Is it? Wait, it's pi over 2. Do we see that? 1 would be the x coordinate because it's flipped. So that's another thing to consider. Do we understand that? Because if it was sideways, then it would kind of be like normal sine except for backwards. But so the y value is actually pi over 2. And that's also a guess from the graph. And then, well, we know this one's just 0. So we can integrate from 0 to pi over 2. And what would we write down then? Yeah, sine of y minus 2 over pi y dy. The hardest part is setting it up. That's hopefully not difficult. All of your problems, if you have the paper, aren't this crazy. Are we okay? Can we continue? So, what's the antiderivative of sine of y? Negative cosine of y. What? Yep. What would this be?
1 over pi y.
Yep. Evaluated from 0 to pi over 2. Plugging in cosine of pi over 2, that's... What's cosine of pi over 2? 0. Minus... What is this? Pi squared over 4 divided by pi. What's cosine of 0? I'm plugging in 1. So I get negative 1 there. I'm plugging in the 0. Cosine of 0 is positive 1, and then I have a negative out in front of it. And then minus 0. So this would be negative pi over 4 plus 1. We aren't done. Because this was the area of just that.
Yeah, that's what I was going to say.
So we need to multiply by 2. Yes, thank you. So then it's negative pi over 2 plus 2. Very good.